Hello, everyone, and welcome back to Geology 106. Today, we are going to be talking about ocean sediments, and we went over so much material yesterday that we don't have as much to go over today, which is kind of awesome. We only have like 10 slides that we're going to be going over today. And the time is 2:53, and we will begin at 3 o'clock. So if you are watching this in retrospect, you can fast forward several minutes. Let's see. So how is everyone doing today? I see we only have one person who I'm asking, though, right now. How are you doing today? I will get a few other things ready on my laptop. Here, all set up for lecture. So how are you guys doing today? I dug out some of my shells from my, I don't really know if you can call it a collection. I don't really have that many, but I have some sand dollars, right? This big giant guy here. Ooh, I should have grabbed my moon snail. I have this giant shell. It's not that big. Nice little clam there. Echo says lazy. I've also got a couple other shells to show you guys. Why not, since we don't really have much else to do other than talk about how we are or, what's going on. So here's how I'm doing. I'm looking at shells. So I think I found this guy, this one. This one wasn't I found most of these except these two greenish colored gastropods here. Those two I did not find myself, but the other guys, beach combing, there's still sand in this one. This one's a rather nice gastropod there. Shells are cool. You know what? I'm going to be right back. I'm going to see if I can interrupt my husband over in his office. Hopefully he's not in a meeting. And I'm going to go try and grab my moon snail because it's just so cool. A pretty awesome shell. And I found it here in this state. So can't remember which beach it was at. I think it was more like somewhere on Whidbey Island, maybe, kind of around some like mud flats and stuff. I'll be right back. Are you in a meeting? Oh, great. Oh, what a bummer. My moon snail shell is still packed away. I was hoping to show you guys in case any of you guys are interested in shells. But I found a few other things and some rocks back here that I'm going to reference in lecture today. that's really cool. Noah says that he has some shells from New Zealand. I really hope to go to New Zealand someday. I am a really big nerd. The main reason why I want to go to New Zealand is because Lord of the Rings was filmed there, and I really want to go see Hobbiton, and also some of the amazing locations that they filmed on there in New Zealand are just like, they're amazing, and I want to see those sites. So, but they're kind of remote, so who knows how many of them are actually easily accessible. So I found this guy though. This is like an extremely large barnacle. It's so large that it has other barnacles on it. It might not actually be a barnacle. My friend told me the name for this. I think it was semiballus, but it's kind of a barnacle-like shell there, or maybe it is a barnacle, and semiballus just means that it's like the specific type of barnacle. I found this on the same beach, I believe, as that moon snail that I can't find right now, that must be packed away, because I still haven't unpacked after living here for a year and a half. That's what a few of those boxes are. And I do have this other fossil sea critter. This is another ammonite fossil there. This one's been cut in half. And inside the various chambers of this ammonite fossil, some calcite crystals formed in the hollows there. These ones kind of filled up completely though. This is the back side of it here. You can see some of the suture lines of the ammonite there. Ooh, really nicely right there. Those coordinate, these lines here coordinate with this right here, the separation of the various chambers inside that sea critter. I like this one a lot. I think I don't remember where I got it. Probably a rock show or something like that. But so it is 3 o'clock. So let's go ahead and get started. I also wanted to chat about the exams. I was very taken aback by the exam results. I had a really weird distribution. Normally on my exams, oh, I lost my eraser. Oh, there it is. My eraser is not an eraser, it's a cloth. Normally the distribution for my exams tends to be like this. Draw a quick thing. So for my exams, normally I have a few A's, a lot of B's, some C's, and then a few D's and F's. That's a typical bell curve for my exams that I give. However, this time it was more like this a bit, where there was only 1 A and 2 B's, and the majority of grades were C's, and then there were a few that were lower than C's. Yeah, I was really surprised by those results because I almost never get that. Sometimes I get bimodal, where people either did extremely well on my exams or you did terrible. I don't normally get bimodal results though. Normally everyone hovers around that B. So I'm not sure what exactly happened there. I did try to make my exam not too much harder, not really much harder at all than a normal exam that I would give. And I can tell that some of you guys were checking out stuff on the internet. Again, that's allowed. Yeah, online exams are weird. And again, checking things out online is allowed, but it definitely seemed like I can tell which answers kind of come straight off of Google, and that's totally fine, permitted. But I can tell if the majority of your answers came off of Google. rather than like straight out of the book. So I think there was a lot of Googling, and totally fine. However, I noticed that a lot of those exams didn't still have very high scores. And I think part of that is due to the time limit. There's just not enough time. 45 minutes isn't enough time to really teach yourself the material. So if you found yourself like in that boat when you were taking the exam and you're like, oh, I thought I knew this stuff better, and I'm having to Google a lot of things or look them up on the spot, I highly recommend taking notes during lecture. If you take notes during lecture, you'll find that you learn the material a lot better and that it sticks in your memory. And then when you come to an exam, you're not frantically like looking things up online or in your book, and you'll hardly need your notes. I also was kind of surprised because I really do try to teach the things that I want you guys to know. And then I also try to test on the things that we covered, as well as things that I really want you guys to know. And thus, my class content tends to be what's on the exam. It's very rare that you'll find something on my exam that is not a concept that we didn't talk about in class. And for that reason, I think I normally get a distribution of scores that are in like the B range. But yeah, some people might criticize me and say, you're teaching to your exams. And it's like, no, I just both teach and test on the things I want you guys to know. And thus, by nature, my exams, it seems like I'm teaching to my exams. I'm not going to test you guys on stuff that I don't think is relevant. And if it's relevant, I'm going to try to talk about it in class. So anyways, my recommendations are to take notes during lecture, and then I think you'll find that that'll help bring your exam scores up. Yeah, and I also really took issue when I was a student and teachers would test on things that weren't covered in class, and they wouldn't test on the things that were covered in class. It was like, I understand that there's a certain amount of responsibility where you can't cover everything in class, so I may need to cover stuff that you guys didn't, that like an instructor didn't talk about in class, but like, it would always really bother me if they talked about stuff in class and none of that was on the exam, and the exam was everything that they didn't talk about. Yeah, so I see a comment, got to preserve the bell curve. I'm not really about preserving the bell curve. Normally, that's just the bell curve that I end up getting. And quite frankly, the bell curve tends to kind of look like that. I would say on average, the bell curve either hovers its peak around B or C. Of course, there are plenty of times where instructors get bimodal bell curves, or in this instance, like the bell curve was shifted over towards C, where mine is normally around B. But I think that it also depends on what kind of content you're testing on. I think that if you're testing in like math or physics, I think bimodal bell curves are a little bit more common there. But a bell curve hovering around B or C is very standard. It's just kind of the nature of results, the statistical results that you're going to get. So, but anywho, enough about that. My recommendation to doing better on the next exam, again, is just taking notes during class. And I think that'll really help you guys out. So let's go ahead and talk about lecture. It's going to be a short lecture today, guys, because we covered so much of what I wanted to talk about in this chapter yesterday. So we're basically just going to be talking about ocean sediments today. So I have the slides posted there on Canvas. If you guys want to head over there. Not any moving pictures today, but And also another easy thing that you guys can do, I'm not sure how many of you guys are familiar with this, but you can actually open the PowerPoint link that I've provided on Canvas, and it's a view only link. However, you can go to File and drop down File on that, and you can go down to Make a Copy and then select Entire Presentation or Selected Slides, and it will open a copy that is your own copy of this slide in Google, and then you can just make your own notes on it right there. So that's kind of a handy tip for you guys. So let's go ahead and talk about what is slide 37 on this presentation, ocean sediments. So the vast majority of the ocean is actually covered in sediment. So it is a basaltic composition, the floor, you know, with those pillow basalts and stuff. However, it's largely also just been covered in sediment from the raining down of like animal skeletons and things like plankton skeletons and stuff like that. And also dust that's been blown from the continents and whatnot. Settling out into the ocean. So these are deposited in two ways. So ocean sediments, regardless of what kind of ocean sediment it is, the manner in which it is, you know, we talked about like transport and deposition. So the two ways the different kinds of sediment that we're going to be talking about are deposited is either through turbidity currents. Those turbidity currents bring sediment down off of the continental shelf onto the ocean floor, or sediments somehow find their way into the water or are creatures in the water that die out, and it rains down through the ocean and then settles onto the ocean floor. So that turbidity currents and the slowly settling out from the waters above are the two ways that those sediments get deposited. And what types of sediments are there that are deposited in these two fashions? Well, there are three types of ocean sediments. There really is like another way that ocean sediments are deposited. But we'll just leave it at that for now, and I'll mention it later in the lecture. There are three types of ocean sediments. There's terrigenous, also called lithogenic. There's biogenous, which is, you know, critters. And then there is hydrogenous, and we'll get to that. We'll define each of these three as we go on. And I've put pictures there of all three different types on this next slide here. The top one showing that terrigenous or lithogenic sediments, where it's just mineral grains and bits of rock and things. And then biogenous, being that it's, you know, was from a critter of some kind. A creature made whatever bit that is, whether it was part of their body or is their whole body or just like a fragment of the shell that they made when they were living. And then that bottom one there, hydrogenous, that one's a bit more complicated. So we'll talk about that more later. I'll save that one. So moving on to talking specifically about terrigenous sediment, so also known as lithogenous sediment. So these are basically just, as I said, they're mineral grains that are weathered from the continent, right? And then transported to the ocean, that terrigenous meaning like terrain. So think land. This is rocks and things from land that have been worn down and then into just tiny bits and fragments and then transported into ocean waters from water runoff from streams, etc., what have you, and then brought onto the continental shelf and are now there in the ocean on the continental shelf or brought further into the ocean through turbidity currents. And I've got 2 photographs there. These are very small mineral grains that you're looking at in those, and they're very rounded because they've been transported quite a ways from their original home on the continent. So just keeping on going through these slides, looking at the next slide dedicated to terrigenous sediment or terrigenous sediment. So the larger particles that are like sand, varying sand size, or that are gravel size, I have a picture down below there so you can kind of get a feel for what I mean when I say gravel or various sand sizes, right? Those settle out pretty rapidly and they settle out near the shore. Kind of like beach sand, but the ocean floor, exactly. Beach sand, but in the ocean. So these sand and gravel pieces, they're larger, they're more dense, right? Ocean water, it has a limited amount of energy, and when I say energy, I really do mean energy. And just like I might not be able to carry this boulder, well, it's not a boulder, but this larger rock, it's eventually going to get so heavy that I'm going to want to drop it. Whereas like this smaller rock, I could carry this a bit farther. I have more energy to do so. Well, ocean waves, depending on how much energy is in those ocean waves, can carry things certain distances, right? And these bigger, heavier things, such as gravel and sand, aren't going to be able to travel as far just because ocean, it can't carry it too far. This is just gonna settle out. However, smaller particles like silt and clay, in the bottom there you can see a depiction of silt and clay. It's like powder. And when I play around with it and have to work with it in the lab, as I do at least a few times a year, it gets everywhere because it's powder. So those smaller silt and clay particles, those can travel so much further because it doesn't take hardly any effort to transport something that's so small and so lightweight. So because it's so small and so lightweight, these can actually take years to settle out of the ocean. It can be suspended in that water for an extraordinarily long time. And because it is also so small and lightweight, it can travel thousands of kilometers, being carried by ocean currents. So thousands of kilometers it can go before it finally settles out. And then also it's important to note too that every ocean has some kind of, or every area of the ocean has some type of terrigenous sediment, whether it's silt and clay or the sand and gravel size stuff. Every area of the ocean has at least some sediment that is from the continents. That's kind of crazy to think about when you think about how big some oceans are, and knowing that this stuff is just all over. Right? Yeah, a lot of beaches in Washington do have more coarse gravel and sand. As a kid, I used to go to a particularly rocky beach up in Birch Bay, Washington, that had a lot of extraordinarily large terrigenous sediment, if you can even call it that at that point. It's pretty much just a very extraordinarily rocky beach. And you had to wear like water moccasin type shoes or water sock type shoes in order to not hurt your feet so much. So let's go ahead and talk about the next type of sediment. We don't see this as much here in Washington. We see a little bit on the beaches of this biogenous sediment, but if you go down to places like, I believe, the Carolinas and the Floridas, their beaches are almost completely like biogenous sediments. So what are biogenous sediments? They are the shells and skeletons of marine animals. So these guys here, this Got a sand dollar and a clam here. So, they're the broken down pieces of shell fragments or just the skeletons of things like plankton and algae and other organisms that live in the ocean. So most biogenous sediment, though, that's in the ocean isn't large fragments like this. It's actually mostly composed of microscopic organisms. So I have two photos below there on that slide, and one of them you can see kind of the larger types of biogenous sediment where it's like broken shell fragments. There's some, those are actually, no, sorry. Those aren't broken shells and things. Those are actually pretty small. I think there's like foraminifera and things like that in there. But compared to what is depicted on the right-hand side of that slide, it's a lot larger. The stuff that's on the right-hand side there is that microscopic organisms, right? So when these organisms die, their remains essentially rain down onto the ocean floor. How many of you guys have watched the Earth Revealed video yet? How many of you guys have had an opportunity to check out this week's Earth Revealed video? If you have, in there, one of the scientists, I mentioned this yesterday, this is how she really describes the deposition of these kinds of particles right on the ocean floor. And if you go back to the first slide that we looked at today, the first slide that we looked at today, it is indeed on the first slide. You can see in the bottom left bottom right corner there, some of that ocean sediment, biogenous sediment, and probably also terrigenous. Rachel has seen the Earth Revealed video. Awesome. And you can see some of that sediment raining down and just kind of covering the landscape. If you blow that picture up large on your screen, you'll see that land that's there is just kind of covered in like this oozy like sediment that's this fine powdery silt and clay. And that's actually a screenshot from the Earth Revealed video itself. So that's kind of just the extent. We're just kind of covering the basics of biogenous sediment. So let's go ahead then and move on to the next type of sediment. This kind is a bit more, there's a bit more things that are encompassed in it. The previous two types of sediment that we talked about, the terrigenous sediment and then the biogenic sediment is very straightforward, right? However, hydrogenous sediments covers several things. So some examples, and we will talk about each of these examples of hydrogenous sediment, are things like manganese nodules. I wish I had thought to bring one with me when I was last on campus, but I forgot. We do actually have some manganese nodules, not quite as interesting looking as the one depicted there, but we do have several manganese nodules on campus. And then also calcium carbonate deposits are included in hydrogenous sediments. Metal sulfides are also included in there, as well as evaporites, right? And you can get evaporites not just in the ocean, but here we are going to talk about them specifically in the ocean. So checking out that next slide there, we will talk exclusively about manganese nodules. So these are essentially rock concretions. What the heck is a concretion? A concretion is something that forms where you have like something that serves as a nucleus, and then you just continue building up layers, kind of like a pearl, and you just continue building up layers around that. So manganese nodules are rock concretions on the sea floor that are formed in these concentric layers, just like a pearl, right? But instead of layers of saliva from a, from a clam, these are layers of iron and manganese hydroxides around some sort of core or nucleus that the iron and manganese adhere onto and then just keep building up that pearl manganese nodule. And on the bottom left there of what slide number is this? I have to pull it off to the side. Slide 43, you can see a few examples of some different manganese nodules. And then if you look at the right-hand side of that slide, you will see a picture of part of the ocean floor that is just completely covered in manganese nodules. And there are plenty of places in the ocean where the seafloor looks like this, where it's just covered in manganese nodules. You can also see some sediment there as well. I'm not sure if that's biogenic sediments or if it is terrigenous sediments, probably a mix of both. So let's go ahead then and take a look at the next slide there, talking about calcium carbonates in these hydrogenous sediments. So calcium carbonate, it's that same stuff that limestone is made out of, that a lot of shells are made out of, right? And when you put hydrochloric acid on it, it starts to fizz because there's a chemical reaction taking place. So this is when you have calcium carbonate that precipitates directly out of the seawater. This typically happens in warmer climates where you have this precipitation of calcium carbonate directly from the seawater. And it's basically you have a lot of calcium, right, that's in the water in order for it to precipitate out. And a prime example of this is like oolites. Oolites are they're also kind of like pearls as well, in that you have some sort of nucleus, right? And then calcium carbonate develops on the surface of that and then continues to build up as more calcium carbonate just adheres to that pearl, if you will, that's being created of calcium carbonate. And if this kind of stuff, these calcium carbonates are buried and hardened, you end up with a limestone rock. And if the calcium carbonate deposit that's been precipitating out is in the form of oolites, you will get oolitic limestone. And that's what's depicted there on the right-hand side is an oolitic limestone. I also have some oolitic limestone from California that looks a bit different. I wish I had my other one. I don't know where it is at the moment. I'm going to look briefly on my shelf next to me. Is it over there? No, I should be so fortunate that it would have been. But let's see if I can get this guy to show up here. Oh, it's not showing up very well because it's so small. I have one other one right here, though. These are all from the same location. Can you guys see how, maybe especially over here, how there's all these small blue dots that make up this limestone? Oh, I wish my camera was better. We do what we can, though, in these times. One more try. That surface, you can kind of see it. If you guys could see this in person, it would be so much more distinct. If I have time to dig out my camera this week, which I probably won't, I'll take some pictures for you guys of mine because it's kind of this really pretty blue color, right? It's actually a very lovely kind of bluish gray color. Yeah, you can see them a little bit in this camera, but not very well. And they're tiny too. Maybe this sample. Oh, this sample's actually showing up a bit better. It's still blurry. You can still kind of see it. Maybe on the edge there, you can kind of see it a little bit. If you squint, All right, enough of that. Enough of that. So these calcium carbonate deposits, if you bury them, they can become limestone, especially like if it's oolites. You know that oolitic limestone? They're like little sea pearls that aren't pearls, but a lot of these things kind of form in a similar method to like pearls. Let's talk about the next type of hydrogenous sediment that we're going to be chatting about, which is evaporites. How many of you guys have heard of evaporites before? Maybe a few of you guys. I bet Noah has, because Noah's into like rocks and fossils. So maybe a few other of you guys have heard of evaporites. So evaporites are where you have seawater that's oversaturated with some type of material in it. And essentially, water evaporation also has to be really high for this to take place. So when the water evaporates off, you're left behind with that dissolved load that was in the seawater, right? So you can simulate evaporites. You can do this at home after lecture. Just go ahead and mix up some salt and water in a pan, right? And then over your stove, boil off the water. Has anyone ever done this, by the way? Like boiled down salt water? It's very fascinating if you do. I highly recommend this experiment at home, especially if you're super bored during quarantine and are avoiding studying for my class. You can justify this as studying. Just get like the tiniest bit of salt water so you're barely covering the bottom of the pan, and then start boiling it off. The salt crystals literally start to pop out of the water because the water will become so salty. There's so much salt relative to how much water there is that the water literally can't hold it all anymore. And they actually just like pop out. So Alicia's unintentionally done. Sounds like you've unintentionally done this before. I don't remember when I did this, but I did it at some point and I was surprised because the salt crystals literally like pop out of the water and they make this popping sound. That's exactly what we're talking about here with evaporites. Sometimes it's not always salt though. In that bottom right-hand picture, you're looking at a shoreline in Maine, and there are some salt deposits on the shoreline that have been left behind because the water there was especially salty, I guess, and left behind those evaporated deposits. So if you went up to it, you'd be like, hey, look, this is like this white powdery stuff or whatever. And the ocean just couldn't hold all of that dissolved material anymore. So you've got that seawater becoming oversaturated with this dissolved minerals, right? And what ends up happening is they precipitate out. That's what we call that process when you create an evaporate. It's a solid precipitating out of a liquid. And then these things are heavier than water. So if this forms like in the water, it's actually going to like sink to the bottom once it evaporates or precipitates out of the water. It's going to sink, right? Some minerals that typically get formed as a result of this precipitating out of the water. You get halite. Halite is table salt. Gypsum is another mineral that you get typically, and also anhydrite. Anhydrite's really, I believe, more of like a mineral family, but we're going to let that one slide. We let garnet slide all the time, so we'll let anhydrite slide by. And what you can see there on the left-hand side is a stone there that has served as the nucleus upon which all of it looks like those are salt crystals, because it looks to me, it's a blurry picture, but it looks to me like they might be square-shaped crystal habits. So I have a feeling that that's salt that's actually crusted onto that stone, right? So let's go ahead and take a look at the next slide there and talk about the next type of hydrogenous sediment, and that is metal sulfides. So how many of you guys have heard of black smokers in the ocean? Or geothermal, hydrothermal chimneys, I think they're called sometimes. They're also referred to as geothermal vents. Yeah, some of you guys have watched like the Discovery Channel or something like that back when it was actually, you know, like science and nature related. Pretty sure it's also all reality shows now too. But these are what are called geothermal vents. Yeah, Blue Planet. I love the Blue Planet. That's such a good series. If you haven't watched it, 10 out of 10, highly recommend. So black smokers are these geothermal vents, and they basically eject this superheated water. And that superheated water often, almost always, contains a lot of suspended black sulfide minerals. And that's why the smoke that's coming out of these chimneys is this really intense kind of blackish, grayish color. And it really is just like shooting out of this chimney, essentially, that's in the ocean. What's happening there is that water does, seep into the ocean floor, the sea floor, and that kind of very uppermost portion of the crust. You do actually have groundwater there, just like we do here, on land. You have, there is water in the ground beneath your feet, in between kind of all this, the spare spaces in between the rock and sediment that makes up the ground beneath your feet. So if there's any like volcanic activity in that area where there's a heat source being provided, you can sometimes get superheating of that water in the crust, right? And then it comes out of these black smokers, and it's carrying all of those black sulfide minerals, right? So these are actually really economically significant, or they deposit really economically significant amounts of iron, copper, zinc, lead, and even sometimes gold and silver. And let's see. Oh, Noah's also seen The Blue Planet and owns it on DVD. I think I do too. It's so good. I haven't watched it in a while. Once things like settle down after the quarter, I'll probably end up rewatching it. So yeah, animals living near hydrothermal vents, as Noah says, they rely on a process known as chemosynthesis. I don't really know a lot about biology. I know almost nothing about biology. I was passed through biology in 7th grade. Yeah, they just passed me through that. So I don't know a lot about like chemosynthesis, at least not the details. But these animals, though, there actually are a ton of animals, as Noah's saying, around these geothermal vents. And you can see in the 2 photographs that I provided there, these kind of stringy-like things. Those are actually tube worms. There's also really like interesting kind of like crabs and shellfish type of things around there, as well as like various kinds of shrimp, I believe. And they are all living off of the these black sulfide minerals that are being ejected. They've all found a way to turn that into I guess essentially like food, and they live off of this stuff, right? And the process is called that chemosynthesis. So, and you get these really highly specialized biologic communities around these geothermal vents, and scientists are very interested in studying these because it's kind of served as one of the is kind of served as a starting point for the idea that perhaps life, doesn't necessarily need the sun, and maybe life didn't evolve on the surface of the earth. Maybe it, in the depths of the ocean, right? Stuff like that. So that's where kind of some of those hypotheses come from, is from places like geothermal vents. So let's go ahead and move on to our last slide here. Told you guys today was going to be a shorter day because we covered so much yesterday. Woohoo! So in the book, we talk a little bit about climate data, how these oceanic sediments are actually very good for recording what's happened in the past, specifically with the climate. So the organisms that are in the biogenous sediment help record that, right? Because different organisms prefer different climates. So if we have certain organisms in an area where they no longer live because of the climate in that area, you can then make a pretty good hypothesis that, well, these organisms don't really survive in this kind of climate. So the climate here must have been different at some point in Earth history, right? They can also record temperature changes, right, revealed in the sediment cores that we take from the ocean. So those pictures there that you're seeing of these people kind of examining these really long rows of sediment, those are what we call cores, where scientists have gone in and they've drilled down and extracted sediment in essentially kind of this pipe, like this cylinder of sediment, and then they can study it, and that cylinder goes down depth lengthwise. So you're getting all the various layers of the sediment that's built up on the seafloor there, and you can compare the stuff that's on the top to in the middle and on the bottom, and you can see how things have changed over time and kind of the history of Earth and the seafloor, right? So what you're seeing there are people studying those cores from the ocean bottom. We also take cores of rocks, hard stone as well. And we do that in areas where we're trying to search for economically viable, like mineral resource deposits and things like that, or, like oil and whatnot. So, and with that basically, that concludes our lecture, guys. Elfin, right? Dad joke there. So yeah. So 3:41, we made awesome timing today, guys. I would stick around and offer to do like a live Google Hangouts, but I also actually have a meeting as well today. Spoiler, that's why we covered so much yesterday. And left only like a few things for today. So if you guys do want to chat though about anything that we've talked about today, you can send me an email and we can try and set up a virtual meeting at a different time when we can talk about stuff from today's lecture or yesterday's lecture, or if you even want to go over your exam. So, but yeah, with that, enjoy your guys' weekends. Watch the Earth Reveal videos if you haven't already. And then I will see you guys next week, Monday at 3 o'clock. All right, cheers.